we did ionization enthalpy, right? And did we do anything else the last lecture other than ionization enthalpy? Ionization enthalpy, irregularities in trend, successive ionization enthalpy, and irregularities in the trend of the case of group 30. Fine. Now, today we are going to do the next property, that is electron gain enthalpy. The next property, that is electron gain enthalpy. So please write the topic. Electron gain enthalpy. Okay. What is this? This is delta H EG. And we will sometimes write it as EGE. Electron gain enthalpy. Now, first of all, let us understand what is electron gain enthalpy. So, electron gain enthalpy, it is the energy involved in the addition of one electron to a neutral isolated gaseous atom. We will just say that we have atom A, which is in gaseous state. In gaseous state means it does not have any other atom around it. And gaseous atoms are isolated. So I will give it an electron and it will become A negative. So there will be some energy involved here, and that energy is known as electron gain enthalpy. Now let us talk about this energy involved, whether this process is going to be endothermic or exothermic, whether this process is going to take energy or it is going to liberate energy. So let us suppose we are having sodium atom. Sodium atom has a nuclear charge of 11 because it has 11 protons. Its first shell will have 2 electrons. The second shell will have 8 electrons, 1, 2, 3, 4, 5, 6, 7, and 8. And then its third shell will again have only 1 electron. Now, if I give one more electron to this sodium atom, I'm giving 1 electron here. So what is going to happen? Please see. Don't write these things, guys. Just listen now. So when I give it 1 more electron, so there will be a new electron in this last shell. There will be a new electron in this last shell. Okay, so what are the changes here? So we have just introduced a new electron in the same shell. So no big worry, the shell was already there. We did not have to add a new shell to give for the incoming electron. No, we did not have to add a new shell for the incoming electron. Okay, now let us talk about the attractions that we have here. What I mean by attraction, please see. Here I have positive charge and all of these are electrons, so all of these will be negative charge. So the proton has an interaction, or rather I should say it has attraction between, there will be attraction between this positive and this electron. There will be attraction between this positive and this electron. Similarly, positive and these 8 electrons, and then the last one also. So basically I can say there are 11 attractions here. Is the part about attractions clear? Yes or no, please tell me. Is the part about attractions clear?
Yes, sir.
What about others? Rishita, Shaista, what about you? You understood this?
Yes, sir.
Okay. Now
Yes,
let me now all of you guys tell me how many attractions are there when I give an extra electron. So the number of attraction in this case will be equal to how much? After giving 1 more electron. So see, please see the 11 attraction which were there, they are still there. And we have a new attraction between nucleus and the electron. Now. So in this case, we will be having 12 attractions, correct? Yes or no, please tell me. Correct, Amna. We are having 12 attractions here. So, and what is attraction? Attraction is a good thing or a bad thing? Attraction.
Good thing.
Or a good thing, right? So we are introducing new attractions here. Yeah, correct. So we are introducing new good thing here. That means we are introducing new attractions. That is why, generally speaking, electron gain enthalpy, it always is an exothermic process. It is going to liberate energy. It is going to be exothermic. Its delta H value should be negative. All of you understood why is that? Because we are getting more attraction after we give electron to an atom. Is this clear, guys? Yes or no? Please tell me.
Yes, sir.
No
Yes.
need to write the drawings here. You will write first point. Generally, energy is released on addition of electron to an atom. Okay, so right, delta HEG has usually a negative value. The meaning of negative is that energy is released. Energy is released. Now, let us look at another case. Please see. Also, one more thing, please understand that when we are talking about attractions, so the nucleus here, it already had influence over the complete shell. This third shell was under the influence of nucleus. We just added an electron here. But if I look at the case of noble gases, for example, I have helium that is having 2 positive charge in the nucleus. It is going to have only one shell with 2 electrons. If I add one more electron, so the first shell can accommodate only 2 electrons. That is why the incoming electron will be added in a new shell. This is the second shell. This is my new shell with a new electron. Now, obviously, these nucleus were only attracting and they had focused their attraction on these 2 electrons on the first shell. It was not having any influence after the first shell. But if I am adding a new electron, then what is going to happen? The attraction which was present before, it would be weakened because the positive charge, the nucleus, it has to influence to influence a new shell. So what happens, even though the number of attractions are increasing, but due to the introduction of a new shell, what happens? Electron gain enthalpy of noble gases is endothermic. It is not exothermic. Okay. So please write next part.
Sir, can you explain this again?
Achha. See, the difference here is that here we are having 3 electrons. Okay, so here we have 2 attraction, and here we have 3 attraction. Right? But the intensity of attraction will be very high in this case because the electrons are very nearer to the nucleus, right? And the nucleus, it has to influence only till this region, this first shell. It does not have to go over first shell, right? So all the attractive power is limited to the first shell right now. Whatever power it has for attraction, it is focused on the first shell. But when I add one more electron, then a new shell will be added. Now this addition of new shell itself will require more energy. Also, what will happen? The attraction between the previous 2 electrons will also be weakened. Yes or no? Because right now the nucleus is not only focused on the first shell, it has to also attract the second shell electron. Is that clear? Yes or no, Rishita?
Yes, sir.
So the quality of attraction that we had earlier was way better than the attraction that we have after the addition of electron in the case of noble gases. Okay, so we'll write this and maybe you will understand even more. Please write here. Noble gases have high positive value of delta HEG, that means electron gain enthalpy, meaning energy is required for the addition of electron due to stable. Also, one more thing you should remember is noble gas, they have a stable electronic configuration. They are not reactive, they have a stable electronic configuration, and we are disturbing that stable electronic configuration. So, right, addition of electron due to stable electronic configuration, and also the incoming electron is added to a new orbit requiring high energy. Requiring high energy. Okay. After this, we are going to write the definition of electron gain enthalpy. Please write the energy released when an electron is added to neutral isolated gaseous atom to form an ion called electron gain enthalpy. Another point, electron gain enthalpy is AKA. AKA means also known as electron affinity. Also known as electron affinity. Please let me know if you're done. Guys, all of you done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Now, right, next, factors affecting electron gain enthalpy. All of you understood till here? Yes or no? Any doubts? Please let me know. Factors affecting, no doubt, na?
No, sir.
Factors affecting electron gain enthalpy. Okay. What about you, Shaista? Understood everything till here?
Yes, sir.
No. First of all, you will write what actually delta HEG tells about, so that it will be easier for us to understand the factors. Okay, so please write delta HEG gives an idea about how easily an electron can be added. An electron can be added to a neutral atom. Yeah? So tell me, I have two atoms, A and B. A has, let us suppose, 11 positive charge. The atomic number is 11. That means it is having 11 protons, right? So atomic number is 11. So that means 11 protons. And B has, let us suppose, how much? 17 protons. Yeah. So what do you think? Where should I add the electron and where it will be getting more attraction? In A or B? If I give an electron, tell me, Shaista.
I think it's B, sir. Then we can obtain octet rule.
No, not let's forget about the octet. And we are just talking about the positive and negative charges. Right? Even then, the electron that is added in the B atom, it will be attractive more effectively, correct? Because it is having 17 protons, right? Yes or no? Even for that matter, if I take 16, even if I take 16 protons, then also if I add an electron to the B atom, that electron will be attracted more effectively by the nucleus than the atom A, which is having 11 protons. Is that right? Yes or no? Please tell me. Correct, guys?
Yes, sir.
Yes, sir.
Okay. That means I can say that the electron gain enthalpy, it depends on the nuclear charge. If I have more positive charge in the nucleus, the electron gain enthalpy will be also more. That means the energy released will be higher. But let us suppose A is having 11 and B is having, what I will say, 37. Okay, just see. But when in A atom I am adding any electron, it is going to the third shell. The incoming electron is going to the third shell. And in the 37, in the atomic number, when we have 37, then in that case, please write, we have 1, 2, 3, 4. 37 will be in the 1, 2, 3, 4, fifth, I think it will be, right? So it will have 5 orbit, and the incoming electron, it is going in the 5th orbit. Now you tell me which electron will be happier. That means which electron will get more attraction, A or
A,
B?
sir.
What do you other guys tell me? What do you guys think? Tell me.
B.
A, na? All of you guys think A, right? A, na? Raista, Majabi, Aapke, Bamna.
Yes, sir.
A, right? Fine. So there are two things. Size also matters, right? The atomic size, it is going to matter when we are talking about the electron gain enthalpy. Fine. So first thing that I'm going to write, the factors affecting electron gain enthalpy. Number one is effective nuclear charge. Effective nuclear charge. We also call this Z effective. Maybe if you have not studied Z effective, don't worry. It is just the nuclear charge. The example that we saw, it was perfect example about Z effective. Now, please write Z effective is higher, meaning more attraction for incoming electron. For incoming electron. Okay. Therefore, delta HEG value, rather I should write, so wait a second. So more energy will be released, so that when you read the notes, it will be easy for you guys. So more energy will be released, and the value of delta HEG will be more negative. Got it, guys? Just please tell me.
Yes, sir.
Right. The second factor, that is size of atom. In this, you'll write size increases. So what will happen? Attraction decreases. Therefore, release in energy will also be lower. And if the size is larger, the attraction will be lower and the release in energy will also be lower. Therefore, delta HEG will have less negative value. Or the magnitude of delta HEG will be lower. The magnitude means, that means we are just focusing on the number. We are assuming the sign to be negative always. We are not going to talk about the noble gases, because noble gases, they don't do any reactions also, right? So we are only talking about the atoms which are other than noble gases. So all the other atoms, they have negative value of electron gain enthalpy. So we are just saying that the value will be negative, but the magnitude will be lower. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Yes,
Now
sir.
the third criteria is going to be electronic configuration. This is also going to matter a lot. Electronic configuration. Please write. Stable electronic configuration. Stable electronic configuration, that means you have half-filled electronic configuration, which is stable. Fully filled electronic configuration, they are also stable. So stable electronic configuration, half-filled or fully filled, most of the times, half-filled or fully filled, will have less negative delta HEG, electron gain enthalpy, because tendency to add electron will be less. Why the tendency of adding electron will be less? Well, because the atom is already having a stable electronic configuration, so it does not want to disturb its stable electronic configuration. Okay, so these are the three factors. Now we are going to look at the trends. So please write, what is the trend in the periodic table? So first of all, we'll write, as we move from left to right, as we move from left to right along a period, then what happens? Please write, along a period, left to right, along the period left to right, the Z effective increases because the atomic number increases and the size decreases. Therefore, delta HEG increases along the period left to right. Understood, na? No problem, right? Yes or no?
Yes, sir.
Yes.
Now, next. Right next here. On moving top to bottom in a group, top to bottom in a group, the delta HEG becomes less negative as the size increases. Now, so top to bottom, what happens? Size increases. That is why the electron gain enthalpy becomes quite less. All of you got this? Yes, no, please tell me.
Yes, sir.
Okay. Now, we'll write some remarks. This is the general trend that we have. There will be some irregularity that we will cover in the remarks. Okay. Now, I will just make a rough periodic table. So this is your periodic table like this, the S block, and then you have the D block here, and then you have the P block here, right? And here we will have the noble gas, which I'm not including because their electron gain enthalpies are positive. Now, what is happening here? As we move along a period from left to right, the delta HEG's value, it increases, right? The magnitude increases. So that means the group 17 that we have will have the highest electron gain enthalpy in the respective periods. Right? Yes or no, please tell me. Correct?
Yes, sir.
The first point is that you will write.
Yes,
Please
sir.
write. Halogens have, group 17 is halogens, right? Halogens have the most negative electron gain enthalpy in their respective period. In their respective period. Okay. Now, there is a big anomaly, and that reminds me of a meme by DJ Khaled. All of you know who is DJ Khaled? All
Yes,
of you
sir.
know who is DJ Khaled? All of you know. So he has a meme, right, where he is holding his head. What does that meme says? Suffering from? You have not seen that meme. No. Abdul Hamid ko nahi pata. You have not seen that meme. Suffering from? Suffering with success. नहीं देखा आप लोगों ने? Really, you guys have not seen anything like that?
No, sir.
ऐसा तो नहीं होना चाहिए.
So with the red coat thing or the black one?
No, I will paste the Like you will understand this. This photo, suffering from success. No one has seen this.
No, sir.
That's right. But still. No. Let us talk about fluorine. Okay, let us talk about fluorine. Now, fluorine, it has how many fluorine? Fluorine, the valence shell electron are 7. 1, 2, 3, 4, 5, 6, and 7. And where are these 7 electrons? These are in the second shell. These are in the second shell. Okay, so fluorine was very happy because fluorine was saying, see, I have very small size and my effective nuclear charge is also very high. And I have very small size and my effective nuclear charge is also very high. That means I should have the highest electron gain enthalpy. I should have the highest electron gain enthalpy. But no. Because it is having a very small size, the incoming electron feels a large repulsion from the existing electrons. Right? So when I talk about fluorine and I compare it with chlorine, please see, fluorine will have its valence shell something like this. And chlorine will have its valence shell something like this. So what do you think, guys? Which can accommodate A or B? Which can accommodate more electrons? I mean, which can accommodate 8 electrons more easily? A or B? If I want to place negative charges, tell me, guys. B, right? All of you agree? B will be able to accommodate 8 electrons more easily. Higher,
Yes, sir.
right? So that's what happens with fluorine. Fluorine was getting happy because it was having small size. And in factors affecting electron gain enthalpy, we learned that when the size decreases, the electrons will be near and they will be attracted by the nucleus. But because fluorine has a large number of valence shell electrons, the existing electron, they repel the incoming electron. And that is why the fluorine atom could not get that electron as easily as chlorine is getting. So please write the next point, that is the delta Heg of fluorine versus chlorine. Please write fluorine, which is rather like this. Wait a second. Right from here, the incoming electron. The incoming electron gets the 2p subshell of fluorine, 2p subshell of fluorine, which is compact, and small in size. Leading to electronic repulsions and hence, अब जहां attraction होना था वहां repulsion हो जा रहा है, and hence what will happen, and hence less energy is released. Now in the case of chlorine, what happens? The incoming electron gets the 3p subshell of fluorine, which is larger in size and can easily accommodate the incoming electron. Therefore, delta Heg of fluorine is less than delta Heg of chlorine. And when I talk about delta Heg of fluorine is less than delta Heg of fluorine, I'm talking about the magnitude. I'm not talking about the sign. We don't consider the sign because the sign, negative sign, it only tells us about the release of energy. So I'm talking just about the magnitude. So magnitude of fluorine will be, maybe it will be 45 with a minus sign, and delta Heg of fluorine will be higher. So let us suppose 100 with a negative sign. So please consider, see, when you write it like this, it is obviously going to be wrong mathematically. We cannot say minus 100 is greater than minus 45. Obviously, minus 45 is greater. Okay. But in chemistry, the negative sign, it has a meaning. It does not mean negative in the number line negative. Negative sign means energy is released. Okay, so that is why we are just considering the numbers when we write these inequalities, I would say. All of you got this? Yes or no? Please tell me. समझ में आया सबको?
Yes, sir.
Jabir, Rishita, Shaista,
Yes, sir.
Okay, fine.
Yes, sir.
You write next point. Similarly, delta Heg of oxygen is also less than delta Heg of, after oxygen we have sulfur, then sulfur. Okay, the same reason. Okay. So you will just replace fluorine with oxygen and fluorine with sulfur, and the same reason if they ask this. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Just give me a second. I am looking for a few questions. Yes, we are talking about the electron gain enthalpy. Now, right, next point. Since delta Heg tells about the tendency to accept electron, it gives an idea about non-metallic nature of element. Okay, so non-metallic nature will be directly proportional to the delta Heg. Again, I am talking only about the value, okay, not the negative sign. Delta Heg. Got this? Yes or no, please tell me. Now see, we have a question. Please write this down. Consider the element boron, carbon, nitrogen, fluorine, and silicon. The correct order of their non-metallic character is. So we'll try to compare the delta Heg, thinking in terms of period and group. So you guys are stuck, right? I mean, don't know how to deal with, right now you don't know how to deal with questions. So what I will suggest is that you try to write the period and the group number of all of these elements if you can. I hope you can write for a few. For example, boron, carbon, nitrogen, and fluorine. All of these will belong to second period. Yes or no? Please tell me. Correct, guys? Yes or no? Yeah, very good. And
Yes.
after that, silicon is going to be in the third period. Cassie Geet Sunao Propi, if you remember the, and silicon will be below carbon, right? This will be in the third period, right? Now, first of all, we'll look at the second period and then the third period, because as we go down the group, then what happens? The delta HEG, it decreases, right? Delta HEG, it decreases because the size increases. So let us consider boron, carbon, nitrogen, and fluorine. So when I go from boron, carbon, nitrogen, fluorine, I am moving along with the period. And in the period, obviously, fluorine will have the highest electron gain enthalpy, followed by nitrogen, which comes before it, followed by carbon, which comes before it, and followed by boron, which comes before it. And at last, we'll have the silicon. Right? Yes or no? Please tell me, guys. Correct?
Yes, sir.
Yes.
Okay, so C option will be the right. One of you done? Yes or no? Please tell me.
Yes, sir.
Give me 1 more minute. Let's see another question.
Yes, sir.
So again, we will play with the period number and the group number, right? So if I talk about phosphorus, sulfur, chlorine, so I hope you can see them in a phosphorus, sulfur, chlorine, 15, 16, 17, right? All of these are in phosphorus, sulfur, and chlorine. They belong to the third period. And fluorine, it belongs to the second period. So we expected really that fluorine should have the less electron gain enthalpy, but we have seen the reason right now that fluorine will have, if I compare fluorine and fluorine, then obviously chlorine will have the largest electron gain enthalpy, right? Yes or no? Most negative delta HEG. All of you remember, right? Why we did not take fluorine? Yes or no? Correct, guys?
Yes, sir.
Okay. And obviously, since we are talking about the third period, and if I move along the period like this, so after chlorine, it will be obviously fluorine. And if I move along the period like this, then chlorine will have the maximum, then sulfur, and then phosphorus. So phosphorus will have the least negative delta HEG. Or if you can use it, please tell me.
Yes, sir.
Yes.
Right, next. Electronegativity. Electronegativity is represented by chi. So we have seen chi A and chi B in mole fraction. So that is the capital letter of chi. Okay, so electronegativity is shown by chi. What is this? It's a very important concept, the tendency of an atom to pull electron in a bond. is called electronegativity. Called electronegativity. So if I look at the trends, it's very easy. So if I go in a period, electronegativity is almost similar to the electron gain enthalpy, but electron gain enthalpy is for non-metals and the ionic molecules, because it is accepting electrons. But what electronegativity tells is if that atom is having a bond, then how effectively it can pull electrons. It is not accepting the electron completely, it is just pulling it towards itself in a covalent bond. So in a period, what is going to happen? Left to right. Left to right. The electronegativity will increase as Z effective increases and size decreases. Second, in a group, top to bottom, the electronegativity will decrease as the size increases. Same thing. No, I will write the electronegativity series. Okay, so this is a trend that you have to remember for this chapter. Then because we are learning electronegativity in this class, so I will write the electronegativity series and considering all the atoms, period groups and everything. So please write the most electronegative element is fluorine, followed by oxygen, followed by nitrogen. Then it is followed by chlorine, bromine, the iodine, followed by sulfur, carbon, phosphorus, and hydrogen. There is a trick to remember this. So remember these part with phone, F-O-N, as it is phone. Cl can be call, phone call bro. And ISC, you can pronounce this as ISK, right? Ishq, if you remember, if you know this Hindi word ishq. Or I should write ISHQ, right? Ishq. P, you can write pyar. Ishq kya hai? Ishq pyar. Phone call bro, ishq pyar. All of you got this? Yes or no? Please tell me how to remember the electronegativity
Yes, sir.
series. Okay, so repeat it a few times. You can easily remember it. Phone call bro, ishq pyar. Phone call bro, ishq pyar. This is going to help you till the end of 12th standard. Okay, so phone call bro, ishq pyar. It's very crucial. And phone, the starting part here, it is even more crucial. Okay, Chali, moving on. So we have completed all the properties, and I would like to write the conclusion, whatever we have learned till now. So please write conclusion. All of you wrote the electronegativity series. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
No. In conclusion, you will write. First of all, I will talk about in a period. Left to right. Oh, wait a second. Sorry, Abdul Hamid. Please write it down. You have not. I could not see that chat right. Write it down. Write it down. Done now? Okay. Conclusion in a
Yes,
period
sir.
left to. Yeah, fine. No, actually, Abdul Hamid was right. Okay. In a period left to right, first of all, we discussed the Z effective. So Z effective increases. Secondly, we talked about the atomic size. Tell me, guys, atomic size, what would happen left to right in a period? Those who have done the classes from starting. Atomic size will increase or decrease left to right in a period. Chat में बताए chat would be better. I don't want any cheating. Amna, Abdul Hamid, Aqib, Shaista, if you can also answer. Yes, Rishita, correct. Also, please answer to Salim, not to Learnivio. Yes, Amna, correct. Very good. Those who don't remember, I would suggest to flip some pages and go to the atomic size. Look at the trends Amna is correct. Rishita is correct. Abdul Hamid, Aqib, Mahjabi. Okay, no one is answering. Oh my God. Guys, please start revising. Okay. So atomic size, see, Z effective is increased. That means the nuclear charge is increasing. More positive, that means more attraction. More attraction means electron will be nearer to the nucleus. That means it will be decreasing. Third is ionization enthalpy. So ionization enthalpy, what will be happening? Please see. Ionization enthalpy is the removal of electrons. So I have to remove electron from the influence of protons. Now, as I go from left to right in a period, what's going to happen? The atomic size is decreasing. So electron will be nearer to the nucleus and the Z effective is increasing. The nuclear charge will increase. So the positive charge will also be greater. Positive charge greater, more attraction. Size is smaller, more attraction. So removal of electron will be very difficult. So ionization enthalpy will increase. And here only we can write ionization enthalpy is directly related with what? The metallic character. I mean, not directly proportional, rather it is inversely proportional. Okay, so please write metallic character. Metallic character is all about the tendency to lose electron. So tendency to lose electron decreases character. Right, the fifth one that we saw today, the negative electron gain enthalpy. Negative electron gain enthalpy, obviously it will increase because what's happening? Nuclear charge is increasing and atomic size is decreasing. Now, related to negative electron gain enthalpy is the non-metallic character. Non-metallic property, I will write that not reflected. No why. So that will also increase. Seventh is electronegativity. The electronegativity also increases as we have just seen. Okay, so we are going to discuss the same things for top to bottom in a group. All of you wrote this, Jasola, please tell me. Okay. So this is B.
Finished, sir.
Just a second. In a group. Top to bottom. So in a group, top to bottom, you see all of these properties. Now, Z effective, obviously it is constant. If you remember, Z effective is constant from top to bottom, because what happens? The number of proton also increases and the size also increases. So it almost balances things out. So generally it is constant. Atomic size, rather, it is going to increase. Why? Atomic size will increase because the shell number increases. If the atomic size increases, removal of electron will be easier, so ionization enthalpy will be lower. And metallic character will be higher because removal of electron is easier now. The negative electron gain enthalpy will decrease because the incoming electron will be in a very far away shell as we go from top to bottom. So that is why the non-metallic character will also decrease and the electronegativity will also decrease. All of you got this? Yes or no, please tell me. All of you done, guys? Yes or no, please tell me.
Yes, sir.
Now, there is a note that I forgot to write in the electron gain, electron gain enthalpy remark point. Please write that now. Note. The second electron gain enthalpy. Okay, so the second electron gain enthalpy of an atom will always have positive value. Meaning it is endothermic. That is what we can say successive electron gain enthalpy of an atom is endothermic. All of you done writing? Yes or no? Please tell me.
Finished, sir.
Write a question. Write the question, don't worry, okay? Predict the formula. यहाँ तक लिखिएगा सर. Yeah. Write them here. Right, they're not working. Right in here. Predict the formula of stable binary compounds that would be found by following pair of elements. So there is a bit of theory here, but I did not get into that because it's better to directly deal with questions and understand how to do these type of questions. By the way, you must have seen these questions in 9th standard also, when you were first introduced to atoms and molecules. The chapter is atoms and molecules, and you were introduced to valency, right? Yes or no? Crisscross method, if you guys remember anything from 9th standard. Yes, Shaishta, Rishita, Ankiti, Afib, Amna. Anyone remembers this?
Yes.
Rishita, you remember or you don't remember?
The valency thing, crisscross method, sir?
Yeah, valency thing and crisscross method.
Yes, sir.
Okay. So all of you wrote this? Yes or no, please tell me. All of you wrote this?
Yes, sir.
Okay, so I will tell you how to do the first one and then we can move on to the next. Okay. So first one is lithium and oxygen. So you have to get the valency of both the things, lithium and oxygen. Okay. So what is valency first of all? What is valency and how do I need to remember the valency of each and everything? I would say preferably no, you don't need to remember it, but you should know how to determine the valency. Once you can determine the valency, it will be easier for you to even remember. Right? You will practice it very easily. And if you practice a lot of questions, those things will be there in your life. So valency can be one of two things. It can either be valence electron. I think we have done this, right? Yes or no? Have we done this? Yes or no? Valence electron, or it is 8 minus the valence electron. 8 minus the valence electron. Now, how to get the valence electron? Valence electron, the valence electron is equal to unit digit of group number. But please remember for S and P block only. for SNP block only. Okay, we are going to talk about SNP block only. All of you understood what is the meaning of unit digit of group number? For example, nitrogen. What is the group number of nitrogen? See, if you, see, that is why I told you guys to remember the periodic table, and that is why I gave all the tricks for remembering the periodic table. Tell me, guys, nitrogen, what group? Nana, Patikar,
Group
Aishwarya,
15.
3.
yeah, group 15. Not 3, group 15. Group 3 तो नहीं पढ़ा हम लोगों ने ना. We learned group 1, group 2, and directly 13, 14, 15, 16, 17, and 18. Because we did not learn about the D block, right? So this is group 15. So what will be the valence electron?
5.
What will be the valence? 5 will be the valence electron. Right? Now, please see, valency can be valence electron or 8 minus valence electron or 8 minus valence electron, whatever is, whichever is lower. Whichever is lower. Got it? Yes or no? Please tell me.
Yes, sir.
Okay. So tell me about nitrogen. So nitrogen's valence electron is 5 and 8 minus 5 will be equal to 3. So what is the valency? 5 or 3? What will be the valency? Shaista, tell me.
3.
Yeah, very good. Okay. Valency would be 3. चलिए तो अब इसी तरह से स्टार्ट करते हैं for lithium and oxygen. Okay, so lithium and oxygen. So lithium and oxygen. So lithium is in which group? Tell me, guys. Lithium is in which group?
First group.
First group, right? So lithium is in first group. So one valence electron. So valence electron is 1. So valency will also be equal to 1 only, right? Because 8 minus 1 will be 7. What about oxygen? Which group?
16.
16. So valence electron is 6. 8 minus 6 will be 2, right? So it will be 2 here. Now you can just crisscross. Lithium will get number 2. Oxygen will get the number 1. The compound will be lithium 2, and so it is lithium oxide, but the formula will be lithium 2 and you will have oxygen, Li2O. So the next one, magnesium and nitrogen. Let's do this one. Magnesium and nitrogen. So can you can take the help of periodic table if you want. Okay. Or I will tell the group numbers. Okay. So magnesium's group number, it is in group 2, and nitrogen's group is group 15. Group 2 and group 15. So try to write the valencies and then the formula of compound. This was the answer. Yes, Rishita, correct. Very good. Others, please. What happened? Let me know if you get stuck. Okay. You get stuck somewhere, please let me know. If you have the group number, and if you can't find the valence electron, let me know. If you have the valence electron and you're not sure about valency, let me know. If you're sure about valency, but don't, you're not sure about the molecular formula, then also let me know. No, Shada. Oh no, sorry, Shaista. No. Is that a typo, Shaista?
No, sir. It's like Mg7N2.
Wait a second. So, what is the valence electron in nitrogen? What is the valence electron in nitrogen, Shaista?
3.
No. What did I say? Valence electron will be unit digit of group number, na? Valence electron will be, tell me, unit digit of the group number, right? Yes or no? Oh, what happened?
Yes, sir.
So what is the unit digit of the group number 15? It is 5, right? And you can have 8 minus valence electron. Right, so this will be 3, na? Valency will be 3 for nitrogen, correct? Yes or no?